This is Marino Plumbing LLC. Today is December 9th, 2023. I'm back over here at the EG boiler, EGH, that I worked on. You can see the previous videos. It's the EGH series. It's an EGH. Information's on the other videos. I'm not going to get into that. But anyway, what had to be done here was, if you see the previous videos, the first one and the follow-up, which I'm going to post that one today, of the repair of this heat exchanger draft box, I had to reseal it. Upon testing, this boiler had a low draft. There was no draft here at all. So I had to seal this box. Now, so I had to fabricate tin to seal all this, if you can see it, all the way down, okay? And I used the heat cock because due to certain circumstances, you have to do this to adjust the draft and combustion air. Now this has two spool switches. They're the GX250 for steam. This boiler previously doesn't come equipped with spool switches, which I find crazy. This is a commercial boiler, and it doesn't have a flame rollout. They don't give you them. I don't know why. So this has two spool switches now. So if there's anything wrong with the draft or the chimney and that comes back, it'll shut it off. But the state here in Pennsylvania wants two controls, two pressure controls and two low water cutoffs for the boiler. So this fuel controls is an M+. It's an M+MG2 draft control, barometric damper. This is used for several fuels: natural gas, oil, and wood. Now if you carefully look here, I'm going to lean. This damper seems it's pulling out, but it moves. It moves to the atmosphere. This building is weird. The way this boiler was installed, the flue comes up and goes across. This heater works fine. It drafts, but it drafts to where there's no draft at all, just barely. So I cleaned this in the previous videos and sealed the draft box, and we modified this because I did the protocol testing by covering the draft box, and it assisted and lowered the combustion readings. This was putting out not extremely high, but high levels of carbon monoxide. So I'm going to turn this on, and we're going to see what happens. I raised it 2 degrees. I might have to raise it some more. Then come on. Now I raised it to 76, so we have ignition. And good thing if you're doing HVAC work or plumbing, it's good to carry your personal handheld, because you go into these buildings and houses, you don't know if somebody's emitting. As you see that relieved, it opened backwards. Now that'll gradually close. It's moving, and it's controlling the combustion air. You can see that that's sucked in, you see? So I'm going to hold this steady. Although it's not moving fully, it's regulating the combustion air. It pulled out and I moved in. So that's making this board operational and safe. I used one weight on this. You can see that thing moving. It's flickering. It's not majorly moving, but it's moving, and it's controlling the draft. That's the biggest thing. I'm going to leave this video camera steady so I'm not moving it. And you can see that that thing moves. Some of these go in more, some don't. This one here, very low draft in this building. I believe they make this up to 32-inch, field controls told me. 32-inch barometric damper. I think they make custom too, but this is a 12-inch flue. Set my timer for 10 minutes.
10 minutes, counting down.
So this is the final checkup on this. I wanted to get the video of the damper that I installed. And that's pulled in somewhat. Now, of course, it's not warm, cold today. It's warm. And this has been off for some time because it has a tech mar, but I raised the temperature to run it. Without this boiler would have probably been ruined. I saved it just in the nick of time. The burners were still salvageable. They weren't damaged highly. Cleaned them and resealed the box. So what this is doing is, when this comes on, it's pulling the combustion air from the front of the boiler, going through the burners and up through the cast iron. You get a better heat transfer, and it's operating safely. With around the back, it could have spilled, was probably spilling somewhat from the back draft box because it's so big. And like I said, it barely made the draft. I checked this, you can see the hole down there, the little test cap. This was operating at a 0, minus 0.1 draft, the minimal draft, 1.5. So without that, there was no draft at all. So if this blade kicks out and this gets hot, it'll shut the boiler off. This massive boiler didn't have no safeties. That's something I can't understand why the insurance company that insures these commercial boilers don't require. Just moved that, adjusted that thing. That's moving. Sometimes these things through the core still move. This is where the damper blade rests. That moves these over here are not to be touched. They're factory set. There's other mechanisms on here that prevents this from being a double acting damper. So I couldn't take the video when I did this because I was in a rush and I had to get it done. I didn't rush it, but I didn't have time to make the video. There's some attachments here that make this a single acting for oil. It can be used for oil, wood, coal, I believe, and natural gas, propane. So now you can see that this is moving. This must have got stuck through the course, and that damper will regulate according to the air temperature and the air in the building to maintain a proper draft. Some of these open wide. I have videos and some don't. Now what I did here was, this is an old original coal boiler that went into a chimney, and I guess this had to be changed at some time because this pipe's been here for a while. This may be the second boiler, third boiler, I don't know. So these pipes were original. They were transferred over to here by the original installer. So what I found was there is leaks in here, but the air, combustion air that gets in here, I mean, it's not excessive. I mean, you can see there's leaks coming in. There's air coming in here in that stairwell door, and there's air coming from the back of that building. But I found, I originally closed the damper. There's a damper on here for the chimney. Closed that, and I find by reopening that damper, there's actually air coming down the old chimney as a combustion air, believe it or not, that is making this work now with the barometric damper. So this is an abandoned boiler, but it's still connected to the chimney, and that is cold air that would be coming down through the damper. Now so this, I got my phone in a pile of shit, which I have to clean that off. As you can see, we got to clean that, so I'll be right back. Okay, I came back here. I brought my damn phone into the sewage, and I saved it through with the otter box. But anyway, I don't want to carry this in. So back here, if you can see, I don't want to do it again. I should have brought my light, but there was a damper here, that lever. So I opened that, and it's pulling in air through the chimney. So let's go back to this barometric damper. So set my timer for 5 minutes.
5 minutes, counting down.
As you can see, this is working with the air in the room. Those are fine. And that thing will move accordingly, and that's it. Now if that comes back out all the way, you know, that's because that's the momentum of the draft. That moved out because the draft is weird here, but it's not backdrafting. If this was open, it would come out from the bottom, but since that damper's here, that's being limited, and the spill switches will sense the heat if it's backdrafting fully. But that thing will move and move and move. Let me set this camera steady so you can see it. That's the air movement in this building, how it's operating. Okay, so it's not spilling. It looks like it's coming back, but it's not. That's the momentum of the draft on the air. So this is pulling an air back from this corner. I can feel the cool air coming in from the outside, and that's making the draft work. So what this does is a barometric damper. It controls the combustion air in the draft. And sometimes you have to put these. It's specified in National Fuel Code. This is okay to do, to modify this. For people that are wondering if you can't do it, it can be done. So as you look at that arm up there, that thing is rocking. That's how the air is moving in here. These are a little bit bigger than the MG7 or 8. I mean, this is more metal on here, so you need a lot of air, but it works the same. So that's stabilizing this boiler to operate safely. Prior to this thing was leaking on the top because this draft box was open. There's no CO leaking now. So this is a follow-up video on this EGH Weil Mclain commercial boilers, 490,000, I believe. I don't want to pull the door up. BTU input 495. I wanted to put a inducer on here, but I did the further testing, and tested that draft with my draft gauge, and it's maintaining the draft, so it's not necessary to do the inducer. This coming out is the improper draft. It's a low draft, so this will control that, and then it goes back in. It's not back drafting on. If that draft box was open the way it was originally, then you would have some spillage. But this is stabilizing that problem, because if it comes out fully, then these switches up on the top or the bottom will sense the heat and cut the burners off. So that's doing its job, and it's pulling the air from the bottom through the burners and up through the chimney, and that is relieving the inadequate combustion air and draft. So what this does is control the combustion air in draft. Sometimes the combustion air goes the other way, or it's too forceful, it has to be controlled. you have any boilers, apartment buildings, or your house, if you're seeing this video in Pittsburgh, Pennsylvania, surrounding areas, give me a call if you think you're not being taken care of by the current company you have. I can tell you this, and I'm not bad-mouthing HVAC people, but I find that a lot of these people doing tin work and air conditioning, they don't know too much about hydronic and steam heat. This is what I've been getting from customers calling companies. So if you have any kind of problems with boiler, hot water, or steam heat, give me a call. Hot water heaters, this applies to hot water heaters too, atmospherically vented. I have a video on that. So you can see within the last 5 to 6 minutes, I'm going to run this for another 5 minutes and I'm leaving Saturday. I want to enjoy the rest of the weekend. Set my timer for 5 minutes.
5 minutes, counting down.
That damper's moved considerably to stabilize the draft and the combustion air. So the pressure over this burner is the required amount of pressure, between minus 0.1 to 0.2. I mean, anything more would be excessive, but this has now established the proper draft. Before, I wasn't getting no draft readings with the draft box open. When I covered that draft box for the test, protocol test, I established a safer condition. The carbon monoxide lessened. The carbon monoxide was rising here. Not drastically, but it would increase down the line. So I sold this modification, and it's working. This is a Fuel Controls M+MG2 draft control. So anything over 8 inch, I believe, or 10, I'm not 100% sure. I think it's over 8 inches is the MG1. So you get bigger, it's the M+MG2 draft control. It's a multiple versatile draft control that is used for multiple fuels. And you probably, if you buy this, it has a red gadget here to eliminate the double acting. For gas, you got to have double acting. Oil and wood and coal is single. If you listen, you can hear the flame operating normally. You can see sometimes it kicks out, but it goes back in, stabilizing. It's modulating. The thing is a draft control. It's like a, how do you say, a water pressure regulator. You set it to reduce the high pressure, but this is a modulating draft control. That's what you need to have on these. So you just put these borders in and walk away. You don't know what the heck you're looking at. You cannot use a condensing boiler for a steam application. This is a steam system. It has to go back with a steam boiler, atmospherically vented. You can power vent now. There's a video I have on a steam boiler. You can put a power venter to power vent it outside. But you cannot not make a condensing steam boiler. You need the latent heat. It's impossible to do. So for this type of situation, these things are going to be around. It's too costly to modify the heating system. I blew that from my mouth. So that's how low the draft is, okay? I blew the air in front of this. So it's a very low draft here, although there's combustion air in here. I can feel the cool air. It's the way the application is and how the flue pipe is going into the chimney. Now, me doing that still didn't change the pressure over the burners. It still maintained the correct draft. I'm assuming on a colder day this will work more. It'll take more temperature change for this to swing, because this is heavier than an MG1, you know, like a 4-inch up to 8-inch. Okay, so in the meantime, this is Vince Marino Plumbing LLC in Pittsburgh. I do hydronic and steam heating boilers. If you have any questions, even if you're out of state, you have any troubleshooting, property manager or something, and you can't figure out with the current people you're using what's causing your boiler to run inefficiently or backdraft, give me a call. It's on the website. I have my website, VinceMarinoPlumbingLLC.com. So I hope somebody caught education on this, what's going on here. But this could have been a very dangerous situation, even though this has been in service, I think, for 5 or 6 years. And I mentioned this in the beginning, this boiler was installed wrong. There should have been a swing here and a common header made. I explained this in the earlier video of the situation here. This is a cap off supply. It used to go to the building, I believe, to this boiler right here. See? So this line went to this boiler, which they had the header correct. Okay, they have swings there, see? The original installer with 2 flanges. That is a drip. That is a drip off the header. It's not was not an equalizer. The equalizer came out probably after this, because this was coal. The Hartford, Connecticut Insurance Company invented it. And this is not an equalizer. I specified that in the first video. This is a drip off the header. The equalizer would have had to been placed when they made this. This should have been removed. They have the main vent over here on the return line here. What the hell these people are doing? It's a return line. So the main's right there. The return vent. The main Hoffman vent. It's not a valve. The Hoffman 75, I heard that somewhere watching other people. You can call it a valve. It's not a valve. It is an air vent. Hoffman main air vent. And the radiator valves on the radiators are radiator vents. So this would have had to have a swing and accordingly piped with the Weil Mclain specs. For this situation, since this is low, they probably would have had to put a drop header. And then the header from the manufacturer could have connected to these. The header should have been here. They take a line off to there and a line off to there, and then the equalizer off the end of the header. This is not a header if anybody's looking at a boiler. This is a drip for condensate. That's all that is. They made this. They made it an equalizer, but it is not an equalizer. This is the Hartford loop. So, like I said, whoever put this in, they didn't know what they were doing. So, in the meantime, this is a Vince Marino Plumbing LLC in Pittsburgh. As you can see, the damper's still moving. Until the next Barometric adventure. Arrivederci, happy holidays and happy new year.